All right, this is example 3 from 1.3, the last of the examples. Students don't like these usually. I mean, it's that kind of graph to equation, although we don't actually need to get the equation of the function, so we never have to know that f of x is a restricted absolute function or absolute value function or anything like that. When you do get these questions, they really do us a favor by giving us these kind of discrete shapes where they only exist. I mean, f of x only exists between -4 and +4. So we only have to worry about that within the region. And I really do recommend that the best way of doing this is to talk about some of the kind of distinguishing features of f of x and g of x. Now, if I look at these two shapes as kind of maybe a letter, then they're both v's, right? And so we can talk about the height and the width. And then the last thing that we're going to do is we're going to talk about kind of the unique point on those curves, which I'm going to label as the vertex. And the vertex is really, in this case, where the function changes direction. So the height of my blue function, the lowest point y value is 0, the highest y value is 4. So this has a height, and I'm going to put 4 units on there. The width, my smallest x value is -4, my largest x value is +4. So I'm going to say that my width is 8 units. And then the vertex, again, that's the point where it changes directions. I'll circle that, is actually going to be at the origin, which is 0, 0. Now, the fact that it's at the origin is very important because it means that whatever stretches we do are not going to affect this vertex, because 0 times anything is still 0. So the horizontal stretch and the vertical stretch will not affect that vertex. All right, what we're going to do is we're going to talk about, what's happening or what did that become on g of x. I'm just going to move that up a little bit. And if we look at the height of g of x, my highest value is +10. My lowest value is +2. So the change in my y values, which is the height, is 8. So I'm going to put 8 units here. Now, the way that we turn a height of 4 units into a height of 8 units is that we perform a vertical stretch by 2. Right? This shape is twice as tall, so it's been stretched by a factor of 2. For the width, the lowest x value is -8. The largest x value is -6. I ran out of room there, but the change in that x value, which is the width, is 2. So my red, or g of x, has a width of 2 units. And using the same logic, we can say that we have a horizontal stretch by, so to go from 8 to 2, we have horizontally stretched this by 1/4. Students struggle with this, and it takes practice, that if we have a vertical stretch by 2, it means that my a parameter is 2. If I have a horizontal stretch by 1/4, it means that my b parameter is 4, because whatever b is, the stretch is the reciprocal of that. So logically, the kind of the reverse of that is true, that if we're doing a horizontal stretch by 1/4, then the b parameter is 1 divided by 1/4, and 1 divided by 1/4 is 4. Okay, last piece there is that the vertex has also changed. The vertex of g of x, my red function, looks to me like it's at -7, +2. And therefore, going from 0, 0 to -7, 2 means that I have a horizontal translation 7 units to the left and a vertical translation 2 units up. And using that same logic as we did above, if we horizontally translate 7 units to the left, then h is -7. And if I vertically translate 2 units up, then k is +2. Now, knowing those parameters is the battle. If we can get that, then we can plug those into our formula. And I'm just going to summarize that right here, that we got an a value of 2, a b value of 4, an h value of -7, and a k value of 2. Now, understanding that g of x is a transformed form of f of x, all we have to do is plug our parameters in. And I often try not to, maybe oversimplify some of these lessons, but if you can determine what transformations have occurred, that leads you to the value of the parameters, and then you can then use function notation to talk about exactly what we would do if we knew what f of x was. So for this particular question, and we'll simplify this just a little bit in a second, g of x is going to be 2 times the function f evaluated at 4 times x minus -7 plus 2. So just putting some brackets around the substitutions that I made. I guess I didn't put a bracket on b, but the rest I did. That's really cumbersome and kind of needlessly ugly, which is maybe not the right word. So what I would do is simplify just a little bit, and g of x is 2 times function f evaluated at 4 times x plus 7, because we're subtracting a negative above, and then plus 2, and this would be the final answer. Now, this particular form would transform any f of x the exact same way. And if we wanted the specific function we looked at, they would have to either tell us or we could determine what the actual equation for f of x is, and then we could use our function notation to come up with the equation for g of x. Okay, these do take a lot of practice, and I know that can feel a little tedious, especially when you're not able to ask me for help one-on-one. Please, again, I know I've said it before, and I'll try to stop at some point. Do the textbook assignment, check your answers against the solutions in the back of the textbook, and if you are struggling, email. All right, several times now I've created videos just for students, helping them with particular questions. We will try to get that screen share app working correctly, and then you could certainly access my help via that as well. All right,